Hi everyone, welcome to the channel. In this video, we will be talking about nuclear military spacecrafts, the newest way to travel in space. Please remember to like and subscribe. Alright, let's get right into it. Fact 1. Nuclear thermal propulsion. Nuclear thermal propulsion, NTP, represents a revolutionary concept in space travel, offering the potential to significantly enhance the efficiency and capabilities of spacecraft propulsion systems. Unlike traditional chemical propulsion, NTP utilizes the immense energy generated by nuclear reactions to heat propellant, creating a high-speed exhaust that propels the spacecraft forward. In NTP systems, a nuclear reactor heats a propellant, such as hydrogen, to extremely high temperatures. This superheated propellant is then expelled at high velocity through a rocket nozzle, generating thrust. The key advantage of NTP lies in its superior efficiency compared to chemical propulsion, as nuclear reactions yield far greater energy per unit of propellant mass. The potential benefits of NTP are far-reaching. It could substantially reduce travel times for interplanetary missions, making crewed missions to Mars and beyond more feasible by shortening transit durations. Additionally, NTP could enable missions to outer planets and their moons that were previously unattainable due to their distances from Earth. However, challenges exist, including the need for radiation shielding, safety considerations, and managing the complexities of operating a nuclear reactor in space. Alright, let's get into the next fact. Fact 2. CIS Lunar Operations. Nuclear-powered spacecraft hold immense potential for revolutionizing space exploration, particularly for cislunar missions within the Earth-Moon region. These spacecraft utilize nuclear reactors to generate power, offering unparalleled efficiency and endurance compared to traditional chemical propulsion systems. In cislunar space, where sunlight can be limited and the demands of extended missions are high, nuclear-powered propulsion offers consistent energy generation, enabling spacecraft to operate for extended periods without the need for frequent solar recharging. This attribute is especially advantageous for scientific research, lunar exploration, and potentially even crewed missions. Nuclear thermal propulsion, which heats propellant using a nuclear reactor and expels it to produce thrust, holds promise for efficiently maneuvering spacecraft in cislunar space. This technology can drastically reduce travel times to and from the Moon, enabling more frequent and ambitious missions. However, utilizing nuclear power in space also presents challenges, including safety concerns and regulatory issues. The potential release of radioactive material in the event of an accident or launch failure requires stringent safety protocols. Their ability to provide sustained power and efficiency aligns with the demands of extended missions in this region. Alright, let's get into the next fact. Fact 3. Fission-based. A nuclear-powered spacecraft utilizing the fission nuclear process represents a revolutionary leap in space exploration capabilities. Unlike conventional spacecraft that rely on chemical propulsion, nuclear-powered spacecraft harness the energy generated through controlled nuclear fission reactions to propel themselves through space. In a fission nuclear process, atoms of a heavy nucleus, such as uranium-235 or plutonium-239, are split into smaller fragments, releasing an immense amount of energy in the form of heat. This heat is then converted into thrust by heating a propellant, usually hydrogen, to high temperatures and expelling it at high velocities through a rocket nozzle. This process generates significantly higher propulsion efficiencies and thrust compared to traditional chemical propulsion methods, enabling spacecraft to reach higher speeds and explore distant celestial bodies. The potential of nuclear-powered spacecraft is especially noteworthy for deep space missions, where vast distances and long travel times necessitate efficient propulsion systems. By utilizing nuclear fission, these spacecraft can achieve faster interplanetary travel, reduced mission durations, and the ability to carry larger payloads or more sophisticated scientific instruments. However, the deployment of nuclear-powered spacecraft also raises important safety and environmental considerations due to the radioactive nature of fission reactions, offering enhanced propulsion capabilities for missions that were once deemed impractical due to vast distances and time constraints. Alright, let's get into the next fact. Fact 4. NEVRA Program. The Nuclear Engine for Rocket Vehicle Application, NERVA, program was a groundbreaking initiative that laid the foundation for the development of nuclear space propulsion systems. Conducted by NASA and the Atomic Energy Commission, AEC, during the 1960s and 1970s, the program aimed to explore the feasibility of using nuclear thermal propulsion for space exploration. NERVA focused on developing nuclear engines that utilize the heat generated by a nuclear reactor to heat a propellant, such as hydrogen, producing high-velocity exhaust that could propel spacecraft more efficiently than conventional chemical rockets. This concept promised significantly higher thrust and specific impulse, essential for enabling crewed missions to destinations like Mars and beyond. Although the NERVA program never saw full operational deployment, its research and testing significantly advanced our understanding of nuclear propulsion's potential benefits. Key components of NERVA's research, such as reactor design, hydrogen propellant systems, and radiation shielding, have influenced subsequent nuclear propulsion projects. The knowledge gained from NERVA contributed to the evolution of nuclear propulsion concepts, including current endeavors like Project Prometheus and the development of ion propulsion systems for interplanetary missions. Today, as interest in crewed missions to Mars and deep space exploration grows, the foundational principles established by the NERVA program continue to influence ongoing research and development efforts aimed at creating more efficient and powerful propulsion systems for space travel. Alright, let's get into the next and final fact. $499 million contract. The development of nuclear space propulsion, with an investment totaling $499 million, represents a significant financial commitment towards advancing space travel technology. This substantial investment underscores the strategic importance of achieving more efficient and capable propulsion systems for future space exploration missions. Nuclear propulsion holds the promise of revolutionizing space travel by harnessing the immense energy released from nuclear reactions to propel spacecraft at unprecedented speeds. The $499 million invested in this endeavor demonstrates the recognition of the potential benefits that nuclear propulsion can offer, including reduced travel times, increased payload capacities, and the ability to explore distant celestial bodies. The significant cost reflects the complexities inherent in nuclear propulsion development. This includes engineering intricate reactor systems. Alright, that is it for the video today. Thank you so much for watching. Please remember to like and subscribe. See you next time.